Right then, this video will look at the problems with the products that are produced from the combustion of hydrocarbon fuels. We know that there are a few direct products from the combustion of hydrocarbon fuels. Carbon dioxide, when there is complete combustion, carbon monoxide and carbon from the incomplete combustion of hydrocarbon fuels. There is also unburnt hydrocarbons that can be released from an engine or from wherever we are combusting hydrocarbon fuels. There are two other indirect products from the combustion of fossil fuels as well. They are sulfur dioxide and nitrogen oxides. The oxides of nitrogen, which is sometimes abbreviated to NOx, because there are several different oxides of nitrogen that are produced. Okay, let's look at these in turn. First of all, the complete combustion of fossil fuels releases carbon dioxide. We know that carbon dioxide is a greenhouse gas. Why is it a greenhouse gas? Because greenhouse gases absorb heat energy or infrared energy. So when there is a lot of greenhouse gases, aka carbon dioxide as an example, they absorb heat energy in the atmosphere. By absorbing the heat energy, they trap heat energy in the atmosphere, and by trapping that heat energy in the atmosphere, that in turn then warms the atmosphere up, and the warming up of the atmosphere is global warming. Global warming is then leading to climate change, habitat loss, severe weather or climate conditions, and sea level rise due to the melting of the polar ice caps, and many other things that many people are getting more aware of when they watch excellent shows on TV. A little bit extra on this, I'll do a little diagram. There's the sun. The sun emits, gives out lots of light energy. Its energy, its visible light in particular, so the light from the sun travels from the sun through the vacuum of space to the planet Earth. I'll do it in this kind of colour here. And here's the planet Earth. Obviously this is not to scale, but the Earth's surface warms up when the light from the sun hits it. Something that is warm, you may know from physics, gives off heat energy. Heat energy is very different from the light from the sun, but the warm Earth then gives off infrared heat energy. Now, if there were no greenhouse gases in the atmosphere, that heat energy would all escape into space and the planet's surface would be cold. The greenhouse effect is very useful because it traps heat energy in the atmosphere. Unfortunately, because we have an increased number of greenhouse gases, or an increased amount of greenhouse gases in the atmosphere, we're absorbing more heat energy. So more heat energy is trapped in the atmosphere is warming more. This is actually called the enhanced greenhouse effect. So I should put on here the little stages. Is radiated. Now what happens is that the greenhouse gas, I'll do it in brown, so number 4, the greenhouse gas absorb it and trap that heat energy in the atmosphere, instead of it just radiating out into space and it can trap it there for quite some time. So if I just go through that one more time, light energy from the sun travels to the earth, warms the earth's surface up, warm things give off heat energy. That heat energy would normally, with no greenhouse gases, go straight into space, and our planet would be a frozen ball. However, greenhouse gases absorb and trap that heat energy in the atmosphere. The enhanced greenhouse effect is due to more greenhouse gases being in the atmosphere, which trap more heat, therefore the temperature will increase even more, to a greater extent. Right, number 2, carbon monoxide. So if incomplete combustion takes place, carbon monoxide can be produced. Now, carbon monoxide is a toxic gas. You can't smell it, you can't taste it, you can't see it, it's colourless. But the most important factor that we need to know about is that it's toxic. Toxic means it will kill you, or it can kill you. The method in which it's the method or the modus operandi, whatever you want to say, the way that it kills you, carbon monoxide irreversibly binds hemoglobin in your blood, in your red blood cells. Irreversibly binds to it where the oxygen would normally bind to it. Once carbon monoxide has been absorbed into the red blood cell and is stuck to forever the hemoglobin until your blood is replaced a few months later, it means that the blood cannot transport oxygen around the body. So the more carbon monoxide that you breathe in, the fewer red blood cells you will have that can transport oxygen. If you can't transport oxygen around your body, cells start to be starved of oxygen, and then they will die. You will basically get a headache, you will fall asleep, and you will die in your sleep. Sorry about the vehicle reversing outside if you can hear the beeping. Right then, the next one, carbon, aka soot. So, carbon, aka soot. It can trigger respiratory problems, it can asthma attacks and other respiratory problems can be triggered by it. It also causes something called global dimming. Because it is a black solid, it can basically reflect or absorb, well, it absorbs mostly some of the light coming from the sun, so it creates a darker environment, very much like the old smog back in the day. It also makes buildings black, and that costs money to remove. So it causes other respiratory problems, many respiratory problems, global dimming, and makes buildings black. That's about it. Unburnt hydrocarbons, unburnt hydrocarbons, so these unburnt hydrocarbons, they can also trigger photochemical smogs, asthma, respiratory problems, and they also could be carcinogenic. To be honest, I don't know why I've added this because it's not in your syllabus, but never mind, and I don't really want to talk about it.